The figure shows the transport level security. The transport mode ESP is used to encrypt and optionally authenticate the data carried by IP. Let us see the scope of ESP encryption and authentication in the transport mode before applying ESP. The figure shows an IPv4 packet and IPv6 packet before applying the ESP. Let us see how the ESP is going to be applied, in how this is going to be get visible, that IPv packet, how it's going to be get visible. For this mode using IPv4, the ESP header is inserted. The ESP header is inserted into the IP packet immediately prior to the transport layer header TCP, and ESP trailer is placed after the IP packet. If authentication is selected, the ESP authentication data field is applied or added after the ESP trailer. The entire transport level segment plus the ESP trailer are encrypted. Authentication covers all the cipher plus the ESP header. In the context of IPv6, ESP is viewed as end-to-end payload. That is, it is not examined or processed by the intermediate routers. Therefore, the ESP header appears after the IPv6 base header and the hub-by-hub routing and fragment extension header. The destination options extension header could appear before or after the ESP header. It depends upon the semantic decision. For IPv6, encryption covers the entire transport level segment plus ESP trailer plus destination options. Extension header, if it occurs after the ESP header, again authentication covers the ciphertext plus ESP header. A transport mode operation may be summarized as: at the source, the block of data consisting of ESP trailer plus the entire transport layer segment is encrypted, and the plaintext of this block is replaced with its ciphertext to form the IP packet for transmission. Authentication is added if this option is selected. The packet is the source, or the packet is the packet is then routed to the destination. Each intermediate router needs to examine and process the IP header plus any plaintext IP extension headers, but does not need to examine the ciphertext. The destination mode examines and processes the IP header plus any plaintext IP extension headers. Then, on the basis of this SPI in the ESP header, the destination node decrypts the remainder of the packet to recover the plaintext transport layer segment. A transport mode operation provides confidentiality for any application that uses it, thus avoiding the need of implementation or implement confidentiality in every individual applications. One drawback to this mode is that it is possible to do traffic analysis on transmitted packets. Let us see how the protocol operation for ESP is going to be happen in transport mode. In the IP security, the ESP origin, the segment is going to be look like this. In the IP layer, in the TCP layer, and the application layer consists of a data. Let us discuss about the next mode of operation, tunnel mode. Already we are aware about that the tunnel mode provides protection to the entire IP packet and secure gateway implementations, which adds a new header for the next hub and also encrypts and optionally authenticates the inner packet and authenticates the entire inner packet and selected portions of the outer IP header. And it's good for private network, virtual private networks and gateway to gateway security. Let us see how this tunnel mode is going to be working in a virtual private network. A tunnel mode operations can be used to set up a virtual private network. In this example or this figure, an organization has 4 private networks interconnected across the internet. Hosts on the internal networks use the internet for transport of a data but do not interact with other internet based hosts. By terminating the tunnels at the security gateway to each internal network, the configuration allows the host to avoid implementing the security capabilities. The former technique is supported by a transport mode security SA, while the later technique uses a tunnel mode security associations. Let us see about the scope of ESP, encryption and authentication for the tunnel mode. The tunnel mode ESP is used to encrypt an entire IP packet. For this mode, before applying an ESP, how the TCP segment is going to be IPv4 and IPv6. We'll see how the ESP header is prefixed to that. The ESP header is prefixed to the packet, and then packet plus ESP trailer is encrypted. Because the IP header contains the destination address and possibly source routing directives and hub by hub option information, it is not possibly simple to transit the encrypted IP packet prefixed by the ESP header. Intermediate routers would be unable to process such a packet. Therefore, it is necessary to encapsulate the entire block, ESP header plus ciphertext plus authentication data. With a new IP header that will contain sufficient information for routing but not for traffic analysis, whereas the transport mode is suitable for protecting connections between hosts that supports the ESP feature. The tunnel mode is useful in a configuration that includes a firewall or other sort of security gateway that protects a trusted network from external networks. In this latter case, encryption occurs only between an external host and the security gateway or between two security gateways. This relieves host on the internal network of the processing burden of encryption and simplifies the key distribution task by reducing the number of needed keys. Further, it thwarts traffic analysis based on ultimate destination. Consider a case in which an external host wishes to communicate with a host on an internal network protected by a firewall, and in which ESP is implemented in the external host and the firewall. The source appears an inner IP packet with the destination address of the target internal host. This packet is prefixed by an ESP header. Then the packet and ESP trailer are encrypted and authenticated. Data may be added. The resulting block is encapsulated with a new IP header, base header plus optional extension such as routing and hub by hub option for IPv6, whose destination address is the firewall. This forms the outer IP packet. The outer packet is routed to the destination firewall. Each intermediate router needs to examine and process the outer IP header plus any outer IP extension headers, but does not need to examine the ciphertext. The destination firewall examines and processes the outer IP header plus any outer IP extension headers. Then on the basis of the SPI in the ESP header, the destination mode decrypts the remainder of the packet to recover the plain text inner IP packet. This packet is then transmitted in the internal network. The inner packet is routed through 0 or more routers in the internal network to the destination host. Let us see how the protocol architecture for this tunnel mode is. In this, the TCP segment looks in IP secured layer, IP layer, after the secured IP layer, in the TCP, and finally data is going to be available at the application. So in this video, we come across encapsulating security payload, how the payload is going to be present, and we have come across with the format of ESP, how the format is going to be work in the ESP, then algorithms, padding and anti-replay services in ESP, the scopes of ESP encryption and authentication for both the modes of operation, transport mode and tunnel mode, and the operation of a protocol, how it's going to be in the tunnel and transport mode. So if you have any queries, please post to me. Thank you for watching this video. Thank you. See you in the next video.